Welcome to our journey through the cosmos. I'm Jacob, and it's a genuine thrill to have you with us as we embark on an exploration of the vast, awe-inspiring universe that surrounds us. There's an entire celestial neighborhood out there, filled with wonders that challenge our understanding and ignite our curiosity. From the fiery hearts of distant stars to the silent, frozen plains of remote dwarf planets, each celestial body tells a unique story, a chapter in the grand epic of cosmic evolution. It's a narrative written in the language of physics and chemistry, a story that we, as sentient beings on this pale blue dot, are privileged to decipher. Today, we're diving into some fascinating facts about the planets Mercury and Venus. These aren't just any planets, they are our closest planetary neighbors, the first two worlds outward from our Sun. Each holds secrets and showcases extreme conditions that make Earth seem like a tranquil oasis in comparison. We'll be peeling back the layers of these enigmatic worlds, examining what makes them tick, from their scorching surfaces to their dense and, in one case, almost non-existent atmospheres. Think of it as a cosmic safari, where we get to observe these incredible celestial beasts in their natural, often brutal habitats. Our mission, should you choose to accept it, is to expand our cosmic perspective, to understand not just these planets are, but they are the way they are. How does their proximity to the Sun shape their destinies? What can their extreme environments teach us about planetary science and indeed about the delicate balance that makes life possible here on Earth? So buckle up your metaphorical space helmets, because we're about to venture into the inner solar system, a realm of fire and intrigue. Let's get started on this enlightening voyage. Now, let's turn our attention to Mercury, the innermost planet of our solar system. Named after the swift Roman messenger god, Mercury lives up to its namesake by zipping around the Sun faster than any other planet, completing an orbit in a mere 88 Earth days. Imagine celebrating a birthday every 3 months. This rapid transit is a direct consequence of its proximity to our star. The Sun's gravitational pull is immensely powerful at this distance, dictating Mercury's swift pace. It's a cosmic dance, a perpetual high-speed chase where Mercury is forever tethered to the Sun's immense gravitational influence, never straying too far from its fiery master. This proximity, however, comes at a tremendous cost, particularly when we consider temperature. Mercury experiences some of the most extreme temperature swings in the entire solar system. During its long day, and a Mercurian day, from one sunrise to the next, lasts about 176 Earth days, which is quite counterintuitive given its short year. The surface facing the Sun can reach a blistering 800 degrees Fahrenheit, or about 430 degrees Celsius. That's hot enough to melt lead, a truly infernal environment. You wouldn't want to plan a summer vacation there, that's for certain. This intense heat is a direct consequence of being so close to the solar furnace. But here's where things get truly fascinating. Despite this searing heat, Mercury also experiences unimaginable cold. Because Mercury has virtually no atmosphere to trap heat and distribute it around the planet, its night side, facing away from the Sun, plummets to an incredibly frigid minus 290 degrees Fahrenheit, or about minus 180 degrees Celsius. This dramatic diurnal temperature variation is almost unparalleled. It's a world of extremes, a place where you could simultaneously be vaporized and flash frozen depending on whether you're standing in sunlight or shadow. This lack of a thermal blanket is key to understanding Mercury's harsh reality. The reason for this lack of atmosphere is twofold. Firstly, Mercury is a small planet, only slightly larger than Earth's moon. Its gravitational pull is weak, roughly 38% of Earth's. This means it struggles to hold onto any substantial gaseous envelope. Any gases that might have once existed would have found it relatively easy to achieve escape velocity and drift off into space. Secondly, its proximity to the Sun means it's constantly battered by the solar wind, a stream of charged particles flowing outwards from the Sun. This relentless solar onslaught effectively strips away any fledgling atmosphere that might try to form. So what we have is a barren, rocky world, pockmarked with craters much like our moon, telling a story of eons of impacts from asteroids and comets, without an atmosphere to burn up incoming meteoroids or weather its surface features. These scars remain almost perfectly preserved, a testament to the violent history of the early solar system. These craters serve as a historical record, allowing planetary scientists to decode the bombardment history that all inner planets, including Earth, experienced billions of years ago. Each impact crater is a chapter in Mercury's long and tumultuous existence, a silent witness to cosmic events. Intriguingly, despite the scorching temperatures, scientists have found evidence of water ice at Mercury's poles. Now, how is this possible on a planet where the sunlit side can melt lead? The answer lies in the shadows. The craters at Mercury's poles are permanently shadowed, meaning their floors never see sunlight. In these perpetual twilight zones, temperatures remain consistently low enough for water ice to persist for billions of years. This discovery was a major surprise and highlights that even the most extreme environments can harbor unexpected secrets, forcing us to reconsider our assumptions about where water can exist in the solar system. Therefore, Mercury presents us with a stark yet compelling vision of a planet shaped by its star. It's a world of blistering heat, bone-chilling cold, rapid orbits, and ancient icy secrets hidden in perpetual darkness. It's a testament to the raw power of stellar proximity and the consequences of insufficient gravity to maintain a protective atmospheric blanket. Studying Mercury helps us understand the lower limits of planetary habitability and the diverse range of conditions that can exist even within a single solar system like our own. It's a crucial piece in the puzzle of planetary formation and evolution. Let's now journey to our other celestial neighbor, Venus. Often called Earth's sister planet due to its similar size, mass, and proximity to us in the solar system, Venus could not be more different in its environmental conditions. If Mercury is a world of extremes dictated by direct solar radiation and lack thereof, Venus is a world where its own atmosphere has created an inferno. It's a cautionary tale written in the skies of another world, a lesson in atmospheric physics gone terribly, terribly wrong from a human perspective, of course. The universe doesn't have a wrong, it just has physics. The most striking feature of Venus is its incredibly thick atmosphere, composed almost entirely about 96.5% of carbon dioxide, a potent greenhouse gas. This atmosphere is so dense that the surface pressure on Venus is over 90 times that of Earth's. Imagine being nearly a kilometer or over half a mile deep in Earth's oceans. That's the kind of crushing pressure you'd experience on the Venusian surface. This dense blanket of CO2 is the primary culprit behind Venus's extreme conditions, a suffocating shroud that has sealed the planet's fate. This atmospheric pressure alone would make human exploration an extraordinary challenge. This thick carbon dioxide atmosphere has led to a runaway greenhouse effect. Sunlight, primarily visible light, penetrates the atmosphere and warms the surface of the planet. The surface then attempts to radiate this heat back into space as infrared radiation. However, the CO2 in the atmosphere is exceptionally good at trapping this outgoing infrared heat, preventing it from escaping. The result? A relentless buildup of thermal energy, turning Venus into the hottest planet in our solar system, even though Mercury is closer to the Sun. It's a planetary oven, constantly on self-clean, and when I say hot, I mean astonishingly hot. The average surface temperature on Venus is a staggering 864 degrees Fahrenheit, or about 462 degrees Celsius. This is hotter than Mercury's sunlit side, and it's uniformly hot across the entire planet, from equator to poles, day and night. There's no cool night side on Venus to offer respite, no shadowy craters hiding ice. The thick atmosphere is incredibly efficient at distributing the heat globally, ensuring that every square inch of the surface remains at this infernal temperature. Lead would be a puddle on Venus, zinc would melt, and some types of rocks might even begin to glow faintly from the heat. Furthermore, the clouds on Venus are not made of water vapor like Earth's. Instead, they are composed primarily of sulfuric acid droplets. Yes, sulfuric acid. These highly corrosive clouds perpetually enshroud the planet, making it impossible to see its surface in visible light from space. It took radar mapping by missions like Magellan to finally unveil the Venusian landscape hidden beneath this toxic veil. These clouds also contribute to the planet's high reflectivity, making Venus appear as a bright jewel-like object in our sky, but hiding a truly hellish environment below. Why did Venus, so similar in size and origin to Earth, end up so different? Scientists believe that Venus may have once had liquid water oceans, much like early Earth. However, being closer to the Sun, Venus received more solar radiation. This increased heating would have caused more water to evaporate into the atmosphere. Water vapor itself is a greenhouse gas. As temperatures rose, more water evaporated, leading to even higher temperatures, a positive feedback loop. Eventually, ultraviolet radiation from the Sun would have split the water vapor molecules into hydrogen and oxygen. The light hydrogen would have escaped into space, and the oxygen would have combined with other elements, leaving behind a dry, CO2-rich atmosphere. Thus, Venus stands as a stark warning about the potential for planetary climates to change dramatically. It highlights the critical role of atmospheric composition in determining surface conditions and the delicate balance required to maintain a habitable environment like Earth's. While Earth has a carbon cycle that helps regulate CO2 levels over geological timescales involving oceans and life, Venus lost its ability to sequester carbon, leading to its current superheated state. It is, in a very real sense, a laboratory for understanding greenhouse effects on a planetary scale. Thanks for joining us on this cosmic adventure. We've journeyed to the blistering plains of Mercury and peered through the toxic, superheated atmosphere of Venus. These two worlds, our closest planetary companions, offer profound insights into the diverse conditions that can arise even within a single solar system. They remind us that the universe is not always hospitable, and that the conditions that allow for life as we know it are perhaps more fragile and precious than we often consider. The study of these extreme environments pushes the boundaries of our knowledge and helps us appreciate the uniqueness of our own planet. From Mercury's incredible temperature swings and icy polar shadows to Venus's runaway greenhouse effect and crushing atmospheric pressure, we've seen how proximity to a star and atmospheric composition can sculpt worlds into dramatically different forms. These are not just abstract facts. They are pieces of a larger cosmic puzzle, clues that help us understand planetary formation, evolution, and the potential for habitability elsewhere in the cosmos. Every mission we send, every observation we make, adds another brushstroke to our ever-evolving portrait of the universe. As we continue to explore the heavens, remember that we are all cosmic travelers on this pale blue dot. Keep looking up, keep questioning, and keep marveling at the grandeur that surrounds us. Don't forget to like, subscribe, and hit the bell icon for more amazing space facts and explorations into the wonders of our universe. Until next time, stay curious, and may your sense of wonder always be as vast as the cosmos itself.